One type of survey that you may need to carry out is a site survey. We call this in situ. In this case, you may be surveying either a space where a spool needs to go, or a spool currently tied into a system where the flanges are bolted up. This means you can't measure a flange's main work point directly. When two flanges are bolted together, we refer to one as the design and the other as the tie-in flange, with the design being the flange in the design file, and the tie-in bolted to it. So let's start the first survey. We're going to survey the complete spool measuring the D-points on the tie-in flanges, then again measuring the D-points on the spool flanges. When the two surveys are complete, we'll compare the two reports. Our spool has blinds on the end of each flange to simulate the pipe being in situ. The blinds are acting as the tie-in flanges. For each flange, we measure the following: a minimum of 4 points with good coverage around the diameter of the back face of the flange, also known as D-points. A back point, taken where the spool is or will be. Bolt holes, which can be taken on either side of the flange on the stud ends. And a stop point, taken on the opposite side of the connection. Here, the system has rejected our measurements because the distance between the D-point plane and the stop point is further than expected. To confirm that this measurement is correct, we need to repeat the stop point measurement. Leave the device on the flange, then lift and replace the prism ball. The measurement will be repeated. The system now knows you want to use this point as the stop point. The actual gap can be measured using a tape and updated during the analysis stage. Flange 3 is the final flange to survey. This flange does not have a gap. Once we have finished the survey, we can have a look at the quality assurance report. We can see that all three flanges have good coverage. ECD and plane data will differ more than with FAT flange surveys due to the varying stud locations in the bolt holes. The system warns us that the error magnitude is high because it has detected larger deviations than expected. The warning message asks us if we want to set each flange's fit to alignment rather than position. We say no because the data will not fit properly until we have updated the flange thicknesses and statuses. Now we need to confirm the bolted up statuses and enter the correct offset and gap values if they differ from the defaults. For flange 1, the bolted up status was automatically detected, but we must update the gap and offset details. This flange's gap is 4.4 mm and the flange thickness is 23.7 mm. Flange 2 has the greatest error in the isometric. The gap is 32.1 and the offset is 15 mm. For flange 3, the gap is 0 mm and the offset is 15 mm. When we apply these changes, you will see the major errors reduced to those more expected. Now let's complete the same survey, but on each design flange. Here's flange 1 with the D-points taken on the design flange, and the stop point on the blind. Now for flange 2. As with the previous survey, the system rejects the flange 2 stop point. We take the same stop point again to confirm this measurement. And finally, flange 3. Now let's update AutoMet with the offset information. There is no need to add the gap information because we measured the design flanges, not the tie-in flanges. When we compare the tie-in flange and the design flange measurements, we can see that there is very little difference. So we can see here that measuring a spool on the tie-in or the design flanges makes very little difference to AutoMet, as long as you let AutoMet know about the gaps and offsets when performing the analysis. If you can take D points on the front face of the flange when the flanges are bolted up, this is not considered bolted up in the AutoMet sense. If the D points are on the tie-in flange, the status will be open tie-in. If the D points are on the design flanges, it will be similar to a fab spool survey. In both cases, the stop point must be on the same flange as the D points. Here's a quick recap on how to perform in-situ site surveys. Taking the D points on the design or the tie-in flange should not make a difference to AutoMet. Just remember to let AutoMet know about the flange statuses and the gap and offset details. This will give you an accurate report. And remember to take the back point in the right location. If you're surveying the spool gap, you will need to take the back point in the space where the spool should be, not on the existing tie-in pipework.